This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Save time building in-app chat, voice, and video for mobile and web apps using Senbird. Get to market faster with Senbird's UI Kit, pre-built UI components, best-in-class support, and developer documentation. Join us in companies like Reddit, Delivery Hero, Yahoo Sports, and Hinge. Start your free trial today at senbird.com/chat.
Hi, this is Priyanka Raghavan for Software Engineering Radio, and my guest today is Yaniv Tal, who's the co-founder of The Graph and project lead at Edge and Node. Yaniv has been working in crypto for more than 3 years, and I had asked his team to send me a bio, and one of the things that really struck me from it was pretty interesting was his belief that decentralization will fundamentally transform how humans cooperate. And he feels that this would only be possible if there's a fully decentralized protocol stack in place. So we hope to cover all of this in the show along with the graph. So welcome to the show, Yaniv. It's a pleasure to have you on Software Engineering Radio.
Yeah, thank you so much for having me.
Okay, great. Let's kick off. We have done a few episodes on blockchain, right from episode 297, which was on blockchains, and then smart contracts in episode 356, and then one on Ethereum in episode 343. It's 2021 now, and our last episode was like 3 or 4 years back, and we did, smart contracts and Ethereum. And one of the things from that show was the host quoted the vision of Ethereum, which was a one world computer with distributed nodes and making it programmable to build decentralized apps. So I just want you to tell us about, in this age, I do know that we want to move away from what we have right now, which is our web, which is controlled by these big technology companies. And we want to move away from all of that. So can you explain the relevance of blockchain infrastructure with this in mind?
Absolutely. So, it's been a really exciting time in the crypto space, and, glad to see, renewed interest in the software engineering field generally. So, there's really two big revolutions that are happening now within crypto. One is the decentralized finance, right, which is creating a decentralized money or, large sets of, currencies and different contracts and ways of, programming money and finance. And the second is this Web3 space, which is, decentralizing information systems as a whole. And the problem that, we're solving is that, all software today basically is, run, owned, and controlled by whatever company it is that's providing the software. And it's very easy to just assume that that is, how it always was, and that's how it always will be. But, the history of software is, really quite rich with changes in paradigms in computing. Starting with, mainframe computers where, you only had large corporations that were running these mainframes to, the personal computer where, people were getting their software primarily through, CD-ROMs or floppy disks where they could run that software, locally on their computers. And then now to the web, which has made things a lot more convenient because, you don't have to acquire software like physically through the mail or in a store. You have teams of software developers that can just, issue upgrades, and, it makes, coordinating a lot easier. But, there's this really massive thing that, we're giving up, which is we give complete control over to the companies that are running that software. And what we've seen over the last 20 years is that really creates an extraordinary centralization and concentration of power where there's fewer and fewer companies making more and more decisions around how, everybody can live their lives, run their businesses. And, it's really not great for an open, free society. And so with Web3, we're rebuilding the protocol stack so that you can still have these same kinds of great, internet connected applications, but where users, have a new set of guarantees, and there's no, company or even set of companies that have, control over how the software is run. And instead, you have individuals with a lot more control over, for example, their private data, their reputations, the things that, they're contributing that's theirs. And you can also have more open governance processes so that where there's, many participants that are all, working together in some way, the rules for, how those participants work together is open and transparent and can be upgraded through, transparent governance processes. So, that's what we're working on with Web3, and a ton of progress has been made over the last few years.
Okay. Yaniv, I actually have to ask you a sort of a non-technology question right now. And the reason I'm asking is I live in India, and just last week we have a big press item that was the government is planning to ban Bitcoins as well as, other virtual currencies, and they want to have some more oversight on this. I think of it as like there's some sort of trust deficit that they have. And without going into too many details of that, I wanted to ask you, there are certain countries and maybe, other organizations which have a problem with the blockchain infrastructure. What's your take on that? I was just curious to know before we jump into the, whole the technology.
Yeah, absolutely. I mean, it's not every day that, the global monetary system, sees a change. And certainly, large countries, and I mean, all countries, part of their job is to try to create stability. They also have, a certain amount of like sovereign control that they express through their monetary policy. And, for the last, 100 plus years, there's basically been this link between state and money, the same way that in the past, there was a link between the state and, say, religion, where, if you lived in a certain country, the king and the monarch decided like everyone in this country must, adhere to this religion. And then, famously, in the United States and, many other countries, and now, most, there is a separation there. You're free to choose your own religion. And I think a similar thing is happening now with money, where it's been in the provenance of countries. It's given a lot of power to politicians, to, banks, to, the large established financial, players. And now there's going to be some competition. And so, different countries are grappling with this fact in different ways. I think, the world is a lot more global now. And so there's, a lot more possibility for like international competition in these types of areas. And ultimately, I think the countries that embrace this new technology are just going to be the most competitive ones. And I think, in the early stages of these types of new technologies, it's not as obvious what all of the benefits are, because these things, they really accrue as the technology grows. But I think, with crypto, for example, we're already getting to a place both with decentralized finance and with Web3 where the benefits are, just becoming more and more clear every day. And so it's going to, rapidly get to a point where it's just too hard to ignore. And I think then the policymakers just have to figure out how to deal with that reality.
Great answer. So let's just move on to the meat of the show. I want to talk about the blockchain infrastructure. Referencing your talk from this thing that you do at the Graph Day, there was a talk from 2 years back. I think you talked about, Web3 and Web2 and the differences like what you've just detailed. But you said that certain aspects of Web3 were still not at the level of Web2. You talked about, infrastructure in terms of scalability, performance being not that great, and the UX also not being so good. It's been now 2 years since that talk. So what's your take? How are things measuring up now?
I think we've made a ton of improvements over the last 2 years. So I can go through some of the places where I think things are looking really good. But definitely the Web3 platform is still a platform that, is under construction. Now you're seeing some really great applications already coming out on top of this platform. So I think, that's really exciting. You no longer have to just dream to kind of think about how these decentralized applications might work in the future. There are actually, already quite a few that are live. And so you can see it, but we still have a long way to go. So as far as the infrastructure, Web3 is composed of, maybe a dozen to 24, let's say, different protocols, different layers in the stack. So you've got, blockchains are an important part because they give you this global consensus where you can have, people all over the world that can agree at any given point in time on the state of a shared database. So that's a really important primitive. You've got layer 2 solutions that are built on top of blockchains that allow them to scale because, the base layer chains themselves have to optimize for security. Because anybody can run these nodes, they need to be secure. And, that's inherently, puts a limit to how fast you can process transactions. And so with layer 2s, you can, get a big speed up in the number of transactions that you can process per second. That's an important part of the stack. You've got peer-to-peer protocols. So not everything needs to go directly on a chain. If you're doing some work using an application locally, that data should really never leave your device. You should be able to work in this kind of offline first way. And, that way your private data really remains private. And then if you need to collaborate with some other people, that data should really just be exchanged directly peer to peer. There's just no reason to go through these kind of centralized, intermediaries and services that, have to inspect and relay all of your data just to be able to collaborate, with a coworker. So there's, these sets of peer-to-peer protocols that enable that. We've got things like wallets, which is how people interact with these protocols where you can store your crypto and you can kind of pay for the different services that you're consuming. And, of course, the graph for indexing all of this data and making it easily accessible and actually serving the data to the applications. So these are just a few of the different types of protocols, and there are even more. And we've really seen a lot of progress, in the last 2 years. So Ethereum, for example, is, they launched the phase 0, they call it, of their ETH2, which is just a massive upgrade to the Ethereum blockchain. We're seeing a host of layer 2 solutions, several of which have already been live for some number of months, and several of which are launching in March, this month and coming up. So, it's just a really dynamic time with, new protocols launching, every week. And these protocols that are launching have really been under development over the last 2 years. And so this period right now is one of really rapid innovation, a lot of, new protocols coming to market with, deep research and engineering behind them. And I think this is the year that we then have to stitch together these different protocols into a really cohesive platform and make it really easy for developers to build these decentralized applications on top. And so I see 2021 as being, the big year for Web3 infrastructure. And, we're already seeing the first, amazing applications, being built on top. And, we expect that to accelerate.
Okay. So let's get into the graph. You explained it briefly, but could you just reiterate to our listeners, what's the problem that you're solving? And a lot of articles I've read online has called you the Google of blockchains. Do you like that?
Sure. Yeah. I mean, I think it makes sense because, Google basically, indexes the web, and the graph is, indexing blockchains and all these decentralized networks. So yeah, the problem that we solve is if you want to build a decentralized application on top of these networks, before the graph, it was really hard because, these nodes don't store all of the data in a format that you can consume directly. And so, when we started building on top of Ethereum in 2017, we realized you actually can't, you couldn't at that time build decentralized applications. You would have to actually run a custom proprietary server to index that data and serve that data to your application. And, whenever you have these centralized points of failure, that tends to be where things get like corrupted, where, power struggles ensue because, everyone wants to control the things that are controllable. So we invented the graph, which is, an indexing protocol where developers can build and specify these subgraphs, which are open APIs that anybody can query. It uses GraphQL, which is a really popular query language originally from Facebook, and it's been open source and it's used by a lot of the top web and mobile companies. And so with these subgraphs, you have really easy, convenient access to all of this data, but that data isn't running on proprietary servers. Instead, it's running on a decentralized network. So you can publish these subgraphs to the network, and these indexers are the node operators that participate in this network, and they run, these subgraphs, or they're ingesting the data from the underlying networks, processing them according to these like ETL rules that you give them. They index that data, and then they serve it efficiently to clients. And there's a whole economic system here that creates the right types of incentives for these node operators and for other participants in the network. And the goal of this system is really to index all of the world's public information, allow curators to organize that data in a decentralized way, and then be kind of the backbone in serving all of these decentralized applications.
Okay, so if I were to understand that a little bit, could you run us through a case study? I looked at your blog, and you have something called the query market. So if I was a consumer and I wanted to, I'm at the query market and I'm looking for a particular query, what's the sequence of events I would do with the graph?
Sure. Yeah. So as a developer, let's say you want to build a decentralized application that allows people to, find and purchase NFTs. NFTs are this really exciting, thing happening in the crypto world right now, where people can mint and buy and sell provably rare goods. And one of the areas where this is getting really popular is with art, where you can be an artist and you can now issue your art digitally, and you can have, for example, just a single edition of this piece of art, and you can put it up for auction. People can bid on it, and then they, will own, your, one of one edition piece of art. So it's, a really cool area that's been really kind of blowing up, and it's bringing a lot of now resources to artists, which is awesome. So if you want to build that kind of an application, you would go to the graph, and there's an explorer where you can browse all of the different subgraphs, and you can find subgraphs from, the top NFT projects like Zora and Foundation, Super Rare, Known Origin. And those subgraphs have these GraphQL, schemas. And so GraphQL is this really convenient query language where you don't really have to know too many details about what's happening under the hood. You just kind of ask for the data that you want. It's a very intuitive kind of language, and you can, run a query and get that data, directly back. And so then you have basically this open API endpoint that you can just plug into your front-end application, where you can query for, all of the NFTs that are available for auction, sorted by price, or however you want to query that data. And you can just, drive your user interface directly from that API. So that's kind of how it works from a developer's perspective. And then they are paying query fees into the network, as people use the applications. Now, we're still kind of in this process of migrating these dApps to the decentralized network. So we launched the network in December, and in the first quarter of this year, the big focus was around bootstrapping the supply side, getting all of the indexers on the network. There are some other roles and things that we're focusing on kind of building up that supply. And just yesterday, we announced the migration plan for bringing subgraphs that previously were running on a hosted service that we initially been running just kind of for development while we were working on the decentralized network. And we're going to be migrating those subgraphs to the decentralized network. And so that's when we're going to see all of the micropayments and these kinds of things going into effect for the decentralized network. And so I can share a little bit more details about how that works if you're interested in going into it.
Mm-hmm. Yeah, probably. Actually, there's one more thing I wanted to ask you. You did throw the different players in the architecture of the graph. I think you had used the term curators. Could you maybe tell us the different roles which are there?
Absolutely. So indexers I mentioned are the node operators that they're running the servers. You can think of them as the distributed DevOps team, right? They're your database administrators that you just don't have to think about running servers and databases anymore. You just outsource it all to these indexers. Then the curators are the ones that are organizing all of the data on the graph. So they may be the subgraph developers themselves that are building these subgraphs, or they can just be, anyone who goes through and evaluates the quality of subgraphs. Because anybody can build these subgraphs, it's a permissionless network. You want people whose job it is to evaluate them and figure out which ones are, pulling in accurate data, doing the calculations correctly, are generally useful. And so that's the role that the curators play in the network. And then you've got delegators, who are the ones, they help secure the network by staking tokens on indexers. So with a lot of these decentralized networks, they use staking as a way of enforcing security in the network. And so, it's an open permissionless network. Anyone can participate. But then how do you know that they don't misbehave? So with staking, somebody is locking up tokens, basically as, it's like a bond where if the service provider misbehaves, then they can be slashed, which means that they lose those tokens or taken away. And so that creates the incentive for them to behave according to the rules of the protocol. And so delegators stake their tokens on indexers, and that helps provide this additional, they call it Sybil resistance, but it's kind of, you think of it as security in the network. And then you've got consumers, which are the ones that are actually issuing the queries and paying for the queries using these micropayments. So, this was an idea that, existed early on in the web and it never got implemented. But this idea that you could stream these micropayments for these API calls. And now, for the first time, we can actually do that. And so that's the model in the graph where you pay per query. Now, long term, our vision for Web3 is that users are going to pay for the metered usage of the services that they consume. So, you'll have a wallet on your phone, on your desktop, and, you're just kind of streaming for the metered usage of these different applications. And then in that world, the developers don't actually have to pay for the infrastructure. And that's actually a really important change that enables this kind of, pulling away the reliance on these centralized service providers, because that's kind of the deal that we're in with these large centralized internet companies, is because they're running the infrastructure and because they're the ones paying for it, we basically have to, play by their rules. And if we want to, kind of get our freedom back, then you kind of have to shift the model of who's paying for it. And so this way, it's not a single company that is like running the application, but rather, right, it's these decentralized networks, and then it's the consumers that's paying. And at the end of the day, the cost for the software, is not that high. The amount of database or compute cycles that any, individual uses is fairly marginal. And so it's actually, better to be able to just kind of pay directly for the stuff than, to really kind of get trapped and monetized through, ways that you can't control. So that's kind of the long-term, vision for Web3. But in the short term, because, there's kind of an education component here and some of the tooling still kind of needs to be improved, it's basically the dApp developers, right? The decentralized application developers that are going to be paying for these queries in the network. And so they're, for the time being, those are the consumers. And so that's the different roles in the network.
Interesting. Quite a lot of different concepts there. So you're saying currently, when I go to cloud service provider, I have this as a service model, right? Is my understanding correct that you would be having that kind of a model, or?
Well, in a sense where, you're only paying for what you use, right? So I guess in a sense there, it's most similar to, one of these serverless sort of like function as a service style, cloud offerings where you're paying per query. But the difference is that, with a cloud provider, first of all, it's a single company, say Amazon, that's running those servers. Whereas in, this decentralized network, it's, there's a large number of service providers that are competing. And, in the cloud model, that cloud provider is the one like setting the prices. And, with these decentralized networks, it's an open marketplace. And so all of these different service providers are competing to provide the best service at the lowest price. And so how you design these markets is really like a core part of the protocol design. And you do it in such a way that creates the right incentives for people to really compete and be able to provide better services.
Okay. The next thing I want to ask you is a little bit on also when you return a query from the graph, I don't know if this is a dumb question to ask, but what's the guarantee that the response is correct? Is that guaranteed by the roles that you just explained, or?
Yeah. So the way the V1, Graph Protocol V1 enforces security is every query that you issue, the indexer returns the response along with an attestation. So it's a signed attestation that then the client can use to issue a dispute if they think that the data is incorrect. And so there's this whole kind of like dispute resolution protocol where there's an arbitrator that can come in and adjudicate the dispute. And if the dispute is found to be correct, then the indexer loses their deposit, their stake. And so this is where, the amount of stake that an indexer, has put down in the network basically tells you how much security there is there, because, they can lose that much money. And so, for example, right now in the decentralized network, there are about 170 indexers. Many of them have staked, millions of dollars each in the network, which means if they send you back an incorrect query response, they're on the hook for millions of dollars in that event. And so that's what creates kind of the checks and balances for the indexers to behave correctly.
So that's a lot that we've covered right now with the graph at a high level. So let's move on to a little bit about, as a developer, if I wanted to come onto the graph network and I want to write some code, is there a playground to familiarize oneself?
Yeah, if you go to thegraph.com, we've got really great docs there that can help you get up and running really quickly. And then there's an explorer, which is where you can browse and discover all the different subgraphs that different developers have built. And you can see the GraphQL playground there, where you can just kind of run example queries in the browser and really explore the raw data itself that's being indexed on the graph. So it's really easy to get started, both as a dApp developer, if you want to build basically user interfaces, different applications that just consume all of this data from the graph. Or you can also get started as a subgraph developer and actually build these APIs. And the subgraph developers are, it's a really kind of interesting role, because you're basically, getting in depth, understanding the details of all these different protocols and then abstracting the complexity away. Right? That's what these subgraphs do. So, there are a lot of, for example, DeFi protocols being built on Ethereum where, actually going through the smart contracts, understanding what they're doing is fairly involved. And as a subgraph developer, you can ingest all of that data and put it in a really convenient format that then gives the dApp developers a much easier interface for interacting with these systems. So it's kind of cool to, have this sort of specialization, between these subgraph developers with details of the underlying protocols. The dApp developers then, really don't have to be super technical. You can be more of like, a designer or just a product, engineer, and easily, access like the sum total of this, giant global API that is just made available for you.
I wanted to ask you about this. How do you run these graph nodes? Like, I do see some things on the literature in your blog is, for example, on having two kinds of ways in which you could have a node. You could either have your own infrastructure running this node, or you could have a hosted service. Can you explain that a little bit to our listeners?
Yeah, so, the graph is a decentralized protocol. Everything is open source. So the main kind of code base is called Graph Node. That's the software that does all of this like ETL work, indexes the data, serves the GraphQL APIs. It's written in Rust. And if you want to, run a Graph Node yourself, it's pretty easy to do so. Then in early 2019, the initial team, launched a hosted service where, we were running a bunch of these graph nodes so developers could easily get started building on the graph. that hosted service has been running now for about 2 years, and it's been growing tremendously in usage. And then the decentralized network launched in December. And as we kind of announced, we're going to be, migrating subgraphs over from the hosted service to the decentralized network. So going forward, the main kind of pattern for most developers, we expect that they would use some kind of something that looks and feels like the hosted service, maybe in development. We're going to be announcing some new products, in that area that still makes it like a good development environment. And then once a subgraph is, been tested, you've gone through your own internal QA process, then you'll be able to just publish it to the decentralized network. And that's where it runs long term. And, the beauty of publishing to the decentralized network is that, nobody needs to trust that like some particular team is going to continue to operate those servers correctly, right? You basically, are guaranteed at that point that API will be available as specified for as long as anybody wants to use it. And that's a really cool kind of guarantee that, has never really existed before in software. I can't tell you the number of either, services that I've used or applications that have either, gotten shut down or the team got acquired or, for, whatever reasons they changed product directions. And, it's, this awful part of depending on software that other people run. And so, by actually building software on top of these decentralized networks, we're building these like stable building blocks where, it's pretty incredible to just think like this thing, if someone wants it 100 years from now, it'll be here 100 years from now and continue to run exactly as specified.
So what about updates that you do? I have a little trouble wrapping my head around that. So the updates to like a new, like when you publish something, you say it's there forever. So I have like, coming from this Web 2 world, I have like a little trouble understanding that. It's like, what about like if you want to make some changes to something?
Yeah, absolutely. And of course, we're software developers, things change. And so, the mental model here is similar to that of like immutable data structures. So, if you're familiar with, functional programming principles, with immutable data structures, you accrete changes over time, but the underlying, data itself isn't modified. So you kind of have pointers to these data structures that grow and evolve over time. And so it's kind of similar with, how we kind of construct things in Web3, where, for example, you've got the blockchain, right? The history of data on a blockchain never changes, but new blocks get added, every few seconds. And so it's this kind of like immutable growing data structure. Similarly, there's you could think of it as a protocol, but it's called IPFS, right, the Interplanetary File System, that gives you content address storage, which is a really brilliant idea. Instead of referring to a server URL, google.com/my file, which at any point in time could change, and you'd have no idea, if and why and when, the response at that URL is going to change. With IPFS, all content is content addressed. And so you build up a hash of the file itself. And so you have this, this hash, and that uniquely identifies the file. And if you want to get it from a particular server, you can, or you can, get the file in a peer-to-peer decentralized network. And you can calculate once you've gotten the file, because you can actually run the hash on the content, you can verify the file you got back is the one that you requested. So it's a really powerful primitive. So you kind of like build up with these types of primitives of like immutable data, content addressed storage. And then if you want to put these kind of like mutable handles on those things, then you can. Right? You can say my website is at this URL and it points to this IPFS hash. And that gives me like a stable URL that I can use. But, I have like the full history of the change of that website over time, where I can see like the change list of the IPFS hashes. And so if I want, I can reference a specific version by its content hash, or it's my choice whether I want to assume a little bit more like risk that the thing kind of changes, but I prefer to point to the mutable kind of URI. So that's the general principle.
This is very interesting. So the thing that I want to ask next is on what about the case where do you have like a bug in a smart contract or a query and that leads to some incorrect payment or maybe funds are stolen? I don't know if, when you have that kind of a scenario, what will happen with the graph? How does that handle?
Well, I guess there's maybe two different components to that. One, bugs in smart contracts, they can certainly happen. And I mean, that is one area where, especially as this technology is, fairly new, bugs do happen. And so, this technology is still, a little bit risky and people, just have to be aware of the risks. There are kind of, different layers of solutions to these things. You've got everything from like insurance protocols where if you've got insurance and then there's a bug, then you can get a payout to cover, your losses. Or, there's like dispute resolution kind of protocols. So somebody could lodge a dispute. It goes to some kind of like a court system where people can adjudicate on like, oh, this person should get, this amount of funds back from a pool. So, there's all of these kinds of like primitives that you can build up around these, more underlying kind of immutable building blocks. And so there's a bunch of exploration there. And yeah, as far as data kind of through the graph, I mean, we really kind of depend on the crypto economics of the system. So if you have, for example, a gateway that is your access point to the decentralized network, that gateway can, issue a query against multiple different indexers. It can, compare the responses. It can submit a dispute for you on chain, all, before even sending the response back. And so there are ways to, the querying part itself can be made, very secure, because as I mentioned, the indexers have a lot of stake, kind of securing the network. So yeah, you just, with these decentralized network, security is obviously a really core part of, the protocol's responsibility. Each of these protocols has to kind of design its own kind of, security and have like a security model, and these things just kind of get built up from there.
So everything it's on the responsibility of that particular graph node or sub node to also describe how it wants to handle such situations, is what I'm hearing.
I wouldn't say it like that. I mean, the security is enforced by the protocol. So there's, a whole set of rules at the protocol layer for, how these disputes happen and how to adjudicate the disputes. So the security is enforced by the protocol.
Okay, gotcha. Okay, I'd like to now talk a little bit about the adoption of the graph. So I was, reading some impressive numbers. I think in December 2020, you had something like 10 billion queries. So could you shed some light on what are the numbers you're seeing and what's the adoption rate?
Yeah, I mean, the hosted service, has been growing just at a pretty crazy rate. I mean, I think we're seeing a lot of growth across the entire ecosystem, in both DeFi and Web3. And the graph is this horizontal layer, that's, used across the entire ecosystem, kind of regardless of application. And so, we saw traffic on the hosted service grow 100x, I believe, over last year. And so, the graph is used by, pretty good majority of the projects building in the Ethereum ecosystem. That's where, we've been really focused, so far. And we've recently announced plans to, expand to other blockchains. So this year, big focus is on, indexing all of the data across all these different blockchains and storage networks. And then, from there, really expanding out because, at this point in time, crypto it's well on its way to going mainstream. And so I think there are a lot of developers out there that, have been working at the same kinds of jobs, doing the same thing, for the last like 5-10 years. At a certain point, you get bored, you need some purpose in your life. And a lot of those folks are now discovering crypto. And so I think that's where a lot of the fun is going to come from, as we see more and more protocols and dApps that are tackling, large markets that really affect a large number of people. And we start to see this technology, becoming really transformational.
So I think you've sort of answered to me what's the future of the graph and how you see things progressing. So anything more you'd like to add on the future?
I think it's, first of all, a lot of like the deep kind of like research and engineering problems have been, solved in the space over the last few years. And now, we're really seeing, this stuff, really getting to a certain level of scale that's, really quite exciting. So like one area that I think is just fascinating is decentralized governance. And so you have these protocols, some of which have, $1 billion plus under management, right? That's controlled by the protocols, protocols like Uniswap and Compound and, even the Graph. And so once you have this type of capital controlled by a protocol, then, interesting next question is, how do we distribute these resources? And protocols have to make all kinds of decisions. Smart contract upgrades, if we need to change the rules of the protocol, and, how to distribute resources from these treasuries. And I think that's an area where, we're seeing a lot of innovation because, it's a real, thing facing these protocols. And, you can see this kind of thing really growing out to more and more use cases. If we have protocols in, all these different sectors of the economy, what is a protocol? It's basically an internet native institution, right? It's a thing that's bigger than a corporation, right? It's the next evolution of human organization after corporations, where, corporations are owned and controlled by a set of shareholders that may or may not be the same as the, participants, and they're closed. They tend to be, built around like, proprietary kind of solutions. And there's very much like, inside the corporation and outside the corporation, and they're trusted. It's a trust boundary. Whereas with protocols, there are new ways of organizing people where, there is no such boundary. Anybody can participate in these protocols. They're open. And so they can scale to much larger numbers of people, and so seeing how, these protocols themselves evolve to be able to do more and more complex things, be able to like distribute resources in an effective way to make high quality decisions. I think, that's one of the most fascinating things happening right now. People want to dive in to see what these existing protocols are already doing. It's already very interesting. And it's definitely an area I would keep an eye on.
So I think this is probably the last but one question that I want to ask you. I started off with asking you a very generic question, and I'm going to end with asking you again a very generic question. So any thoughts on this, quantum computing and how it affects the strength of the cryptographic algorithms used in blockchain infrastructure? Sure,
yeah. We still have some time, I think, before quantum computers kind of crack the existing hashing functions. And certainly this has been an area of research for, a lot of smart cryptographers. And I think at this point, there's a pretty well understood, set of quantum resistant, hashing functions and cryptographic primitives. And so they're not being widely deployed yet, but I think they're the types of things where it's a good thing that, these protocols are upgradable. And so, as those primitives get more performant and, we kind of get closer, I think it's just going to be one of these things that these protocols can coordinate on to kind of upgrade to these quantum resistant crypto primitives.
Okay, that's great. So I just like to end by asking you, where can listeners reach you if they wanted to? Would it be Twitter? Could you spell it out for us, for our listeners?
Yeah, absolutely. So the Graph is @Graph Protocol on Twitter. The initial team that built the Graph is @Edge and Node on Twitter. I'm @Yaniv Graph on Twitter. You can check us out at thegraph.com. And we've got a very active Discord community that you can join if you've got any questions. People are super helpful there. We also now have a governance forum at forum.thegraph.com, where we initially propose, any things that are, happening in the protocol. Usually they start out as forum discussions there first.
Okay, I'll make sure I put a lot of that in our show notes for listeners to see. So thank you so much for being on the show, Yaniv. It's been great for me. I think I've learned a lot in the 15 minutes I've spent with you. So much appreciated.
Yeah, thanks, Priyanka. This was a lot of fun.
This is Priyanka Raghavan for Software Engineering Radio, and thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.